Sleep Mode 2 uses the PID generated frequency command to decide when to automatically turn the motor on and off. This is especially important in applications like PID-driven tank filling. I have PID set up to fill this tank to this level. Let's turn the water level LEDs on to make that easier to see, and open the valve a little to create some demand. When I hit run, PID sees the water levels down, so it cranks up the blue frequency command. And that exits the drive as the yellow frequency output, which has the acceleration ramp added in. The red line is the error, the difference between where the water level is and the set point where we want it to be. The error gets smaller and smaller as the water level approaches the set point. And as the water level starts to get close to the set point, PID automatically slows the motor down. Looks like our demo needs to maintain the output frequency at around 16 Hz to maintain the water level at the set point for the particular demand I created by opening that drain valve a little bit. But if we're just filling a tank, do we really need for the drive to be running at 16 Hz to maintain the water level? That's a lot of extra electricity and motor and pump wear and tear that really isn't accomplishing much. And since centrifugal pumps aren't real efficient at mid to low speeds anyway, and it'll actually stop pumping altogether if the frequency gets too low, why not just turn the motor off when the PID commanded frequency starts to get small? And then let the water level drain to some lower level before turning the motor back on. Well, that's where Sleep Mode comes in handy. Sleep Mode 2 monitors the PID command frequency, the blue line on our chart here, and when it sees it slow down enough, it disconnects the blue PID command frequency from the yellow output frequency, which turns the motor off. And as the water level falls, Sleep Mode 2 waits for the PID command frequency to get large again before reconnecting it to the output frequency to the motor. That way, the drive isn't running the motor forever, burning electricity and wearing out those pump and motor parts. Let's add in Sleep Mode to this example so we can see how it works. These are the PID parameters I'm using. There's a separate video showing you how this was done, so we won't do that again here. And these are the Sleep Mode parameters. And we only need a couple of these to get started. First, we need to tell Sleep Mode to watch the PID frequency command to make its decisions. That puts us in Sleep Mode 2. Centrifugal pumps get pretty inefficient below 30 Hz, so let's have Sleep Mode turn the motor off at 30 Hz. As the water level falls, PID is going to automatically raise the command frequency to try and bring the water level back up. It can't because Sleep Mode turned the motor off. PID doesn't know that, so it'll keep increasing the output frequency to try and get that water level to rise. Let's have Sleep Mode turn the motor back on when PID pushes the command frequency past 50 Hz. Well, that's all there is to enabling Sleep Mode 2. Let's try it. Suppose we want our set point to be when a tank is 95% full. Well, 95% of our max drive speed of 60 Hz is 57 Hz, so we enter that here. Remember, because we're using PID, this isn't the drive frequency anymore, it's the set point. I've already set up the GS4 scope function with the PID generator frequency command in blue and the actual output frequency in yellow. These are just analog potentiometers I connected to analog inputs 2 and 3 so we can use them as cursors. Let's adjust those potentiometers to remind us that the sleep level is at 30 Hz and the wake-up level is at 50 Hz. The tank is currently low on water and the valve is closed, so when I hit run, PID sees the low water level, so it would normally crank up the blue drive frequency command. Of course, it was already at 60 Hz when I started this trace, so the yellow output frequency immediately ramped to match it. As the water level approaches the set point, the frequency commands, which are on top of each other right now, start to slow down, and when the blue PID frequency command hits the 30 Hz sleep level we specified, the yellow output frequency goes to 0, which turns the motor off. Perfect. We're now not wasting energy on filling that last little bit. If I open the valve to create some demand, the blue PID frequency command goes up to try and compensate, and when it crosses the green 50 Hz wake-up level, Sleep Mode allows that to pass through to the output frequency, which goes to the motor. Again, exactly what we expect. So now, the GS4 drive is automatically filling the tank as needed by watching that PID generator frequency command, and it's only letting that through to the pump when it's efficient to do so. You can also delay sleep and wake up. Let's set the sleep delay to 2 seconds and the wake up delay to 2 seconds. I'm also going to set this min drive speed to 30 Hz. You'll see why in a minute. Run the same test, and this time, Sleep Mode saw the PID frequency command hit the sleep level, waited 2 seconds, and then turned the motor off. So by adding an appropriate sleep delay, you can get a little extra water in the tank that you didn't get before because sleep mode was shutting the motor down before we reached our set point. This plateau is the output frequency you want the motor to run at during the delay. Maybe you don't want the motor to run at full speed during this time while you're topping off the tank. Or maybe you don't want it to run at all. Well, you can set that speed using parameter 626, the min drive frequency. That'll only be enabled during this sleep delay time. Now one final note. PID is still running while sleep mode has the motor turned off. It can't do anything because the motor's off, but it is trying, which means the integral term is still integrating the entire time the motor's off. Now, depending on your system, this can get quite large, which means it'll take a long time for PID to settle out when the motor does get turned back on. If it's bad enough, the process can completely miss the set point and possibly create a huge mess. The good news is the GS4 drive has this integral limit parameter where you can specify a limit for the max duration of the integral term. That way, you can control how quickly the process recovers after the motor's been off for a while. Well, that ought to be enough to get you going with Sleep Mode 2, where the GS4 drive monitors the PID generator frequency command to make its sleep and wake decisions. Click here to learn more about the GS4 drive. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to Automation Direct's YouTube channel so you'll be notified when we publish new videos.